Welcome, my name's Jeff Bartels. I'm an infrastructure technical specialist here at Autodesk, and today we're going to look at some tips and tricks associated with Civil 3D alignments and profiles. I've got a ton of things I want to show you today, and going to use a kind of a shotgun approach to get through as much as we can during our time together. On screen, you can see a rough outline representing the categories of the tips and tricks we're going to be looking at, everything from creation all the way down to organization. Let me say right off the bat here that when we're talking about alignments and profiles, Civil 3D views these objects similarly. So if I show you a tip associated with an alignment, try it with a profile. It may work there as well, and vice versa. Alignments and profiles use similar toolbars, dialog boxes, workflows, labeling, etc. As always, this is going to be a PowerPoint-free zone. Everything that we do today is going to be live in the application. Okay, taking care of housekeeping, let me drop out of this. I am working in Civil 3D 2022. That said, everything I show you today is going to work regardless of the version of Civil 3D you're using. We're going to start out by looking at how we can set Civil 3D to check for tangency in our alignment geometry. On my screen, I have a polyline, and I would like to create an alignment from this. This is a typical workflow. We want to create an alignment from objects. Now, I generated this geometry myself, so I know that these curves are tangent to these straight segments. However, sometimes you get geometry from others, and you may not have time to go through and validate everything. Let me pull that over just a little bit. At this point, I know that line segment's not tangent to that arc anymore. Let's convert this geometry into an alignment. From the alignment menu, I will choose Create Alignment from Objects. I'm going to select this object, and I'll press Enter. I'll press Enter to accept the direction. I'm going to keep the default name and stylization, and then I'll click OK. And right away, you can see that I have a warning here. If I hover over that, we can see that I have a tangency violation. Now, how can we see the warnings, or how can we ensure that we see the warnings? Two places we have to go. One is with the alignment properties. If I select the alignment and go to alignment properties, here on the design criteria tab, down in the lower right corner, there is a toggle that allows Civil 3D to check for tangency between elements. Now, don't worry, this is turned on by default. If not, you can toggle it on here. Likewise, if for some reason that's not on by default on your end, you can find it over here on the Settings tab. If I go to Settings and I right-click on the Alignment category, Edit Feature Settings, if we come down to the Criteria-Based Design, all the way to the bottom, check for tangency between elements. Right here is where you can assign this as a default for your template file. Okay, so that needs to be turned on. One more thing has to do with the alignment style. If I select the alignment and right-click, and then from the menu choose Edit Alignment Style, I can see here on the Display tab that the alignment style that I'm using is displaying the warning symbols. So you want to make sure these are turned on. You can see if I turn that off and click Apply, it's checking, but it isn't going to show me on screen. So I want to make sure that that is turned on in the style that I am using. So now that I've identified the tangency issue, how can we fix this? I'm going to select the alignment, and then I'm going to come up to the geometry editor, and then I'll click this green ball to bring up the tabular editor. In the tabular editor, we can see the tangency violation here with the little warnings. All we have to do is hover over them. And I can see the curve has a radius of 200 feet. It is considered fixed. If I select this, the curve highlights on screen. That's the entity we're going to edit. Notice if I click the tangency constraint again, we have the option of changing this. And I'm sure you're aware the entities that we create can be fixed, floating, or free. Basically, these designations have to do with tangency. Fixed means it doesn't care about tangency on the left and right. It's a fixed object. Floating maintains tangency on one side or the other, and free will maintain tangency on both sides. So I'm going to set this to be a free curve. When I do, it's now tangent at both ends. Let me go ahead and close this. It has maintained the bearing of this tangent segment coming in and going out. Basically, it just refilleted that arc with a new radius of 200 feet. Okay, so that's how we can check geometry and how we can fix it if we have to. Next, we'll dive a little bit deeper into creating alignments from objects. On my screen, I've got some circles here. I'm going to create a copy of these. Let's copy those down. So same circles in both cases. I'm going to create a polyline, and we will draw the polyline from the center of these circles. And then I would like to fillet this. So I'm going to create a fillet. I'll launch the fillet command. We'll choose radius. I'm going to go with a 200-foot radius. I will click these two entities to round that corner. And now let's create an alignment from this object. I'm going to go to the alignment command. I'll say create alignment from objects. I will select this object. I'll press enter, enter, and enter again to accept the defaults. Perfect. Now let's create a similar alignment using the layout tools. I'm going to go back to the alignment menu, and this time I'll choose Alignment Creation Tools. Going to keep the default name and stylization. Let's click OK. Using this method, I'm creating the alignment using designated tools. And I can create various tangent segments, both fixed, floating, and free. I can create curves, spirals, things like that. For this example, I'm just going to open the menu on the end. If I come down to curve and spiral settings, I just want to show you that by default, it's going to create curves at 200 feet, which is perfect. Let's set this to tangent with curves. I could just go from one circle to the other, and I'll press enter when finished. Let's close this. So I have the exact same geometry in both cases. Now, when I started using Civil 3D, I was of the mindset it really didn't matter how you created your alignment as long as you ended up with the same thing. And in some respects, that's accurate. Where we do find a difference between the objects is when it comes to grip editing. Let me show you what I mean. I will select both of these alignments. And if I zoom in on the one that was created by Layout Tools, you can see that the PI, or the point of intersection here, has a blue grip. If I pan up to this one up above, the one created from Objects has a gray grip. This is considered an implied or an implicit PI. It wasn't calculated. Didn't need to be because I provided the geometry for this. Where that comes into play is when we grip edit the alignments. If I click this grip down at the end and I pull this tangent segment down, my expectation is that it would change the bearing of this line and hold that PI. If I click, you can see that's exactly what it's doing. However, if I try the same thing with an alignment that was created from Objects, as I pull this down, notice it's not pivoting on the PI, it's pivoting at the end point of the geometry that I selected, that tangent segment. If I click, you can see what happens to the PI, which is not what I want. Let me undo that. Now, all is not lost. If I select this alignment and zoom in, you can see that the PI here is gray. If I hover over this, I can choose Solve PI, which will then solve it, which makes it blue. And now, if I select this alignment, click this grip at the end, I can now adjust this, and it will hold that newly calculated PI location. Okay, after seeing that, you may think, all right, good to note. From now on, if I create something from Objects, I may have to go through and solve the PIs. It actually goes a little bit deeper than that. And let me show you another example. Let's say I want to create some geometry that represents a cul-de-sac, or an alignment that represents a cul-de-sac. I've got some geometry representing centerline of road and the edges of pavement. I'm going to come up and I'll create an alignment from Layout Tools first. I'll choose Alignment Creation Tools. We'll keep the defaults here. I'll click OK. And I'm going to create some fixed geometry. I'll just create a fixed line segment from here to here. And I'm still in the command. I'll create one from here to here. And I'll press enter. Notice that even though it's all one alignment, the labels can't jump to the other side because I don't know how to reconcile that gap. Now I'd like to create the head of the cul-de-sac. I'm going to create a fixed curve for this because I don't have other alignment geometry to connect to just yet. So we're going to do this in the fixed category. I'll go to more fixed curves. And if we look in the menu here, I'm going to use this option, fixed curve, center point, and radius. Good rule of thumb with these options, just look in the parentheses and ask yourself, what do I know for creating this geometry? And in this case, I know the center point and radius. I'd like to put the center point of the cul-de-sac head right here. And the alignment geometry is going to go counterclockwise because I'm going in this direction. So we'll choose counterclockwise, and it's going to have a radius of 50 feet. Perfect. Now let's create the fillets that tie these together. To do these, I'm going to create free curves because I would like them to maintain tangency on both sides. I'll go with free curve fillet between two entities with a radius because that's the information I know. I will select this alignment and this one. This is going to be, the solution will be less than 180. Whenever your solution's greater than 180, it creates a great big loop, which is almost never what you want. So I'm going to press enter to accept less than 180. I'm going to be creating a reverse curve as I come through here. And then the radius will be 25 feet. I'll press enter. That looks good. We'll create one on the other side. I will select this part of the alignment and this one. Less than 180, reverse curve, and 25. I'll press enter when finished. I can get rid of these sketch lines now. So here is the geometry for your alignment representing a cul-de-sac that was created from the Layout Tools. Now let's create one from Objects. If you'll indulge me here for 1 second, I am going to trace this. And there's other ways to do this. This is just really quick. I'm going to come through and trace this. We'll go back to the line segment there. There we go. All right. Let's say move. And I will say L for last. I want to move the last object that I created. I'll press enter and I'll move this up. So there's a polyline representation of that geometry. I'm going to create an alignment now from Object. I'm going to reverse the direction there so it's going the same way, and then I'll accept the defaults. Perfect. Exact same alignment in both cases. They're created two different ways. Let's select the alignment created from the layout tools. And I'm going to turn off my object snaps here for a second. If I click this grip on this tangent segment, you can see that this translates as I would expect. It's adjusting the offset for the roadway there. It's tying up the fillet nicely. Notice I have a grip at the center of the cul-de-sac head. I do because that's the way I drew the geometry. I had the center point. If I click the center of this, I can pull it out nicely. I can even flex this in either direction. It just edits as you would expect it to edit, if you were modifying this geometry with grips. Let me press escape. If, however, I select the same geometry that was created from objects, if I click the same grip here in the middle, drag this around, you can see that's not necessarily what I want. I've got no grip at the center. If I click this grip at the end, I could, kind of pull this out and make the cul-de-sac head bigger, but it looks like it's a fixed object. It's not maintaining tangency. Let me click undo. Now you may think, okay, well, I could get in here and I could, solve the PIs. Well, there isn't a PI here because we've got a reverse curve. And, I could select that and I could go to the geometry editor and bring up the tabular editor. I could say, let's take this first curve, and I could set this to be a free curve so it maintains tangency on both sides. So I could kind of reverse engineer this as though I created it using the layout tools, but then it creates a compound curve instead of reverse curve. So could I go through and reverse engineer this and make it work the exact same way? Yeah, I could. But in the long run, if I'd like the more flexible editing, it may be better to create that geometry using the layout tools. No right or wrong way to create an alignment. You can do it however you like. I'm just showing you this to show you that there is a difference between the ability to edit after those alignments are created depending on the method. Let me also mention that I wish this example here was my own idea. It is not. I was watching a demonstration by a gentleman by the name of Matt Kohlberg about a year ago who demonstrated this, and I thought this is just a brilliant way to show the difference between the ways alignments can be edited based on their creation. So I'm using the same example here. Okay, let's pan this up. Next, let's talk about creating alignments using best fit. On my screen, I've got some geometry. I've got a pair of polylines in this case. Let's assume that these polylines represent the left and right bank of a stream or a river or something like that. Maybe I'd like to identify the center line of this. I'd like to create an alignment that represents the center of that stream. If I go to the alignment pull down, I could choose best fit alignment. And this brings up a great big dialog box. In the upper left corner here, I can select the entities that I'm working with. I can do best fit to generate an alignment through selected entities. I'm going to choose AutoCAD entities in this case. You can see the other options that we have. There's a weeding method here. Using weeding, we can cause Civil 3D to ignore excessive or redundant vertices or grips, and we can supplement vertices and grips if we want to. I'm going to keep the defaults. I will then select my path, or path 1. I'll select path 1 here and press enter. Now, if that was all I did, if I just came down and completed this command, it would try and create a best fit alignment through this singular entity. That's not what I want to do. Notice that there is an optional path 2. If I select that and click the other side and press enter, now it's going to try and create an alignment between them. I can now set my minimum radius for curve detection. I'm going to keep the default setting for that. Since I'm creating this for a stream, I'm not going to worry about having it try and understand or create spirals. Don't worry about the stylization or the labeling right now. I don't need to show the report or labels. In the end, I'll come down and click OK. Before I do, let me mention that this is kind of an iterative process. If you don't get exactly what you want the first time through, maybe you can adjust this number a little bit. Maybe you can adjust the weeding options to get a better result. When I click OK, I can see in this case I've got a very nice centerline alignment, and this is created from legitimate geometry. I could go into the geometry editor and I could make changes to this. A real quick way to calculate something like that. Let me push this up. I wish I could say that method is going to function perfectly with every geometry type or configuration that you may come up with. Unfortunately, the more complicated geometry gets, the harder it is to solve something like that. As an example, I've got some additional geometry on screen here. I'm going to say create best fits, and I will select entities. Going to do the exact same settings that I did last time. I'll select my 2 paths, and then no spirals, no report, no labels. And when I click OK, you can see in this case, that's not what I want. The geometry is getting a little too complicated for that to figure it out. Let me undo this. Let's look at a low-tech way to solve a high-tech problem. This is the way we used to solve this type of thing in the old days. I have polylines in this case. If I select this polyline, just imagine if this polyline was set to an elevation of 700. Let me press escape. And then just imagine if this polyline was set to an elevation of 702. If I was to create a surface between these two objects, Civil 3D could calculate the 701 contour, which should fall between them. Let's do that. I'm going to launch the surfaces command. I'll say create surface. I will call this surface stream, and I will change the style. Let's go with proposed 1 and 5 for this. And then I'm going to go to the Modify ribbon tab. I would like to modify a surface. I would like to add data. I'm going to add contours. I will then tap my spacebar because I've got multiple surfaces in this file. I'll choose the surface I want to modify, stream. And then notice we have the supplementing and the weeding factors, just like we did for best fit. I'm going to keep the defaults here, just make it simple. And then I will select this object and this one and press enter. That creates my surface. I will then select the surface, and from the contextual ribbon, I will choose extract from surface. I want to extract objects. I want to extract a minor contour, not all of them, just one from the drawing. I'll click the green block and I will select this one and press enter. I will then click OK. That surface is still selected. I'll press delete because I no longer need it. And you can see I now have a polyline that represents the midline between these objects. Admittedly, it's not perfect. I could now turn around and use the best fit alignment through this entity to get me closer. Depending on how far off this is, I could also go through and make any necessary adjustments. So this is another way to find the midpoint between objects when you have complicated geometry. Let's pan this up. This time we're going to look at some shortcuts for navigating our interface. Maybe I would like to calculate a surface profile for this alignment. If I select the alignment, anytime you select an object in Civil 3D, at the end of the contextual ribbon, you'll find a panel called Launchpad. Launchpad is what Civil 3D uses to anticipate what you might want to do next. In fact, I used this option in the last tip. I used the extract surface objects from surface. That was in the Launchpad. Here, when I select an alignment, it anticipates that I may wish to create a surface profile. So I'm going to create surface profile. I would like to sample through the existing ground surface. Now, I've got multiple surfaces. You may wonder, how does he know that's the existing ground? I could pick it using that green block if I wanted to. Let me click add. I'll choose draw on profile view, create profile view, and then I will place this over here. So just using the Launchpad, I was able to sample that surface profile in a couple clicks. Maybe I'd like to create a finished grade profile. If I select the profile view from the Launchpad, I can go right to Profile Creation Tools. Just 2 clicks and I'm there. I can accept the default name and stylization. Let me click OK. Note the toolbar here is virtually identical to what we use for an alignment. I'm going to use similar commands here. I'm just going to use the draw tangents with curves. And let's go from the endpoint here. And then we'll just pick some points and we'll draw this quickly on screen. There we go. So there's my finished grade profile. I was able to access that in like 2 clicks just using that Launchpad. Let's close this dialog box. I'm going to delete this profile. And let's look at another method. I can create best fit profiles as well, just like I can with alignments. Now, unfortunately, that particular tool is not in the Launchpad, so I'm going to go back to the Home tab. I would like to create a best fit profile through this surface profile. We'll assume that this is the surface for the center line of the road that was calculated from survey points. And I'd like to kind of clean this up, clean up the geometry to do a proposed finished grade roadway center line elevation. If I go to the profile menu, I can say create best fit profile. If I select my profile view, very similar dialog box to what we have with alignments. All I have to do is select my entities or my input type. In this case, I'm best fitting through a surface profile. Note the other options that we have. I can then adjust my weeding options. In this case, I am going to make some modifications. If you've ever sampled a surface profile, you know that there's a ton of vertices in this entity. I'd like to weed some of those out, so I'm going to use the weeding option. And the way weeding works, if you turn this on, it allows you to enter an angle. This is a deflection angle. And if we come over here, the way this functions, if I have 2 entities that create a deflected angle of this amount or less, it will eliminate or ignore the vertex between them and essentially treat that as a straight line. So that's how we can weed out grips. In this case, I'm just going to use a small angle, just 0.1. And then I can also supplement as well. Now, supplementing is not going to help me here, but supplementing helps if I'm creating a tin surface and I've got segments that are quite long without a lot of vertices. What this does is I can say this distance, 30 feet. If I have a segment that is 30 feet or longer, go ahead and triangulate or find a vertex in between those points. Okay, not necessary in this case. Good for 10s, but not for this. I'm going to go ahead and leave the weeding on. Let me click OK. And then the surface profile I'm sampling is the only one that I have in this profile view. I've got a maximum radius for curve detection. Just keeping it simple. I'm accepting all the defaults here. I want parabolic curves. The only thing I am going to do is change the style here. I'm going to go with the proposed style. No reports, no labels. When I click OK, you can see that Civil 3D created a best fit profile through my surface profile to kind of clean this up for me. And this is legitimate profile geometry. This is as though I created it using the layout tools. If I select that profile and go up to Geometry Editor, and then click the green ball to bring up the tabular editor. In fact, I don't even have to go that far. If I want to remove some of these PIs, for instance, I can use this delete PI option and say, you know what, that's kind of redundant. Maybe I could take that one out too. I could come around here and say, you know what, maybe that one's not necessary. Heck, maybe that one's not necessary. So if I had a long stretch of roadway here, I could use this best fit option to go through and clean things up for me rather than trying to trace it manually. And I can make adjustments as necessary. Also note that if I was to use the layout tools, I have the ability to create best fit on a segment by segment basis, both tangent and curve, fixed, floating, and free. Okay, let's look at another option. On my screen, I have an alignment. Let's say this alignment is tied to a subdivision design. We're going to look at how we can do some design checks with our geometry. If I select the alignment, I can come up to the alignment properties. And here on the Design Criteria tab, we've got this toggle where I can say I'd like to use criteria-based design. If you've ever used this before, you've probably turned this on because you've wanted to use the design criteria files. This is where I could select an XML file that represents the AASHTO tables that I'd like to use for super elevation. Notice down here that there is another toggle that says Use Design Check Set. This is where we can define or check our own standards that are over and above what AASHTO may define. For example, you may have municipal standards for subdivisions that say that for a new subdivision, the tangent segments need to be at least 150 feet long. And maybe the radius at the center line of the road on a curve needs to be at least 200 feet. I can go through and set standards so that if I violate those standards, Civil 3D will warn me visually on screen. Let's look at how we can do that. I'm going to hit cancel here for a second. If I come over to the Settings tab, this is where all of our settings are stored. I'm going to expand the alignment category, and I'll come down to Design Checks. And in here, you can see the various components with respect to an alignment that I can check. And in this template, I don't have any checks set up. I'm going to create some new ones here. I'm going to right-click on Line, and I'd like to create a new line check. For the name, I'll say that this needs to be greater than or equal 150 feet tangent required. I like to be very descriptive in my design check names, and we'll see why here in a little bit. Since I'm descriptive in the name, I really don't need a description here. Since I'm checking line segments, if I open this menu, you can see these are all of the aspects with respect to a line that I can check. I would like to validate the length. The length needs to be greater than or equal to 150 feet. Let's click OK. Let's do one for the curve as well. Let's say that we have a minimum radius length of 200 feet. I will create a check for that. We'll say greater than or equal 200 foot radius required. Not going to put a description on that since I'm checking a curve. Here's my list of items associated with arcs. I'm going to choose radius greater than or equal to 200 feet. Now, if I expand this other item here, you can see you can make the math here in these expressions as simple or as complicated as you would like. Let me click OK. Now that I've created a couple checks, what we'll do is we'll create a check set. This way I can assign multiple checks to a single alignment. And in this particular template, I've got a check set here. I'm going to create a new one for this example. I'll right-click on the header and choose New. And I'm going to call this check set Subdivisions. So this would be the check set I would assign to the alignments if they're associated with a subdivision. And now that I've created the set, I can go through and you can see the same categories here that we have here. So I can go shopping under the line category for the requirement that I want. I want the one I created called greater than or equal to 150 feet. And then I want the curve greater than or equal to 200 feet. I'd like to add that to my check set. Let me click OK. Perfect. Now let's assign that to this alignment. If I select the alignment, I will come up to Alignment Properties. And I would like to use criteria-based design. However, I'm not going to be grabbing XML files or tables for the AASHTO standards. Instead, I would just like to use my municipal check set. I'll expand this. I'll choose Subdivisions. And I'll click OK. And no warnings, so that's good. I can see that my geometry doesn't violate those standards. If, however, I grab this radius here and I pull this out, you can see that if I drag it too far, I now get this warning. We can also see a greater than or equal 150-foot tangent required. That's why I'm descriptive, because it's very intuitive here in the tooltips. If I drag this curve down, I get another warning saying that greater than or equal to 200-foot radius required. Now, how can we fix this? We've seen that. If I select my alignment and go to the geometry editor, I can go to the tabular editor here. And in the tabular editor, I can see my check set warnings down at the end. Currently, the radius for this arc is 73 feet. I know that that needs to be at least 200 feet. So I will select that curve, and then I will change its radius to 200, which takes away that warning. Now, I can't enter a new line length or a new tangent length through here because this length is dictated by the radius of those two arcs. I'm going to change the incoming radius here to, this has to be 200 feet or greater. I'm going to make it 250 feet. And I'll press enter, and that creates a longer tangent segment, which now eliminates that other warning. So as I'm editing my geometry, Civil 3D is keeping track of it with respect to those design checks, and it's ensuring that I'm not violating any standards. Now let's talk about how we can create some stylization. I like to create what I call working styles. Working styles makes it easier for me when I'm editing my design. As an example, if I select this alignment, I'm going to come over to the properties and I'm going to change its style. I've got one that I created called layout. And if I assign that and zoom in, with this layout style, I have chosen to colorize the components of this alignment to make them easy to identify. I can easily see the lines, the spirals, and the curves. Note that I'm also displaying arrows that show me the direction of these entities. This can be real helpful when I'm joining entities together or selecting objects, because if for some reason my stationing stops at a particular area and I wonder why, I can look to make sure. Usually it's because I've got an entity that I've connected to that's facing in the other direction. So this is a great working style that I can apply to alignments when I'm doing my design work, because it just visually makes it easy for me to see things. If I select this alignment, we can take a look at the style. I'll right-click on this and I will go to Edit Alignment Style. And you can see that when I created the style here on the Display tab, I just said that for lines, curves, and spirals, I would like to use 3 different colors. The nice thing about working styles is the layer you use, the color you use, line type, none of it matters, because it's not supposed to plot. You set working styles up so that they've got nice contrast on screen. It makes it easier for you to work. You can also see that I have applied a line weight to these. Once again, they're never going to plot, so it doesn't matter. Since I applied a line weight to these, if I come down and click the line weight button to display the line weights here in Model Space, that makes it really easy to see on screen. I create these working styles not just for alignments, but for profiles, surfaces, anything, because it makes it easy to work on the design, and then I can flip it to a plottable style when I'm done. Since we're talking about stylization, let's talk about the MATCHPROP tool. MATCHPROP is an AutoCAD command, but I can use this to pass stylization from one Civil 3D object to another. If I choose MATCHPROP, I will select my alignment. And you can see the paintbrush. I can go up and select another alignment to apply that style to this one. Now I did it with alignments, but try it with other Civil 3D objects. Great tool for passing stylization from one object to another. Okay, let's look at another shortcut here. I'm going to jump to a different drawing. We're going to look at some shortcuts that we can apply to our template to reduce picks and clicks. I jumped to this drawing because this drawing was created from the generic stock Civil 3D template that comes out of the box. So this has just all the default settings, and I want to show you a couple things here that can save time. On my screen, I have a polyline. I'd like to turn this into an alignment, so we've seen this. I'm going to go to Alignment, Create Alignment from Objects. I will select this, and I'll press Enter. I'll press Enter. In the dialog box, notice there's this toggle that says Add Curves Between Tangents. That's on by default. And it used to drive me nuts. Every time I made an alignment from objects, I always went through and unchecked that, because I don't want you changing the geometry or doing anything. I drew it the way I wanted it. I don't need you making any adjustments to this. Did you know you can pre-populate the settings in these dialog boxes? Let's do this. I'm going to close that. And if I come over to the Settings tab, let me do this first. I'm going to press F2 here. I just want to show you that if we view my command line history, that command that I just ran is called Create Alignment Entities. Keep that command name in mind. If I go to the Settings tab, under Alignment, down at the very bottom, there's a Commands option here. If I expand this, you can see every command associated with alignments in Civil 3D. There's that command I just launched. If I double click on this, I can preload the settings for this command. Not just this command, but every command in Civil 3D. Notice that some of the options in this dialog box have a icon with a wrench. These are the settings in the dialog box. Create from entities. I'm going to expand that. Add curves between tangents. Currently that's set to true. I'm going to set this to false, and I'll click OK. This would be the type of thing that you'd set in your template. From now on, whenever I create an alignment from objects, I will never have to deselect that box again. Let me also mention that in that same dialog box, you can preload your styles and your labels as well. Very valuable tool there. You can do that for every command. Let's go ahead and complete that. Create alignment from objects. I will select this, and I'm going to call this alignment, let's call it Main Street, and I'll click OK. Let's look at another option. I would like to pull a surface profile for this. So we've seen if I select the alignment, I can come up to the launch pad, choose surface profile. I'd like to use the Main Street alignment to sample the existing ground surface. When I click add, it used to tear my hair out. I always wanted to name this. You can see no matter how many times I click there, it does not give me the ability to name that surface profile until I actually complete the command, and then I have to go do that later. Instead, let me remove this and I'll cancel. I'm going to have the template name this for me. Coming back over to settings, I'm going to expand the profile category, and I'll come down to commands. Notice there's an option here, create profile from surface. Let's double click. In the dialog box, just like with the other ones, there's an option here for default name format. Let me expand this. Profile name template. Let's click. I'll click the ellipsis button. Here's the default template that's being used for the name of your profiles. I'm going to press delete to take that out. I would prefer that these profiles are named based on the alignment name. Let's insert that. And then I would like a dash. And then I would like to add the sampled surface name after that. Let's click insert. This is more logical. This is going to be automatic, and it'll be the same for everybody. Let me click OK. And OK from now on. If I select my alignment and I go to surface profile and do my sampling, you can see it's got a nice logical name now, Main Street dash existing ground. Let's draw on profile view, create profile view. Now this is going to look different because we're using the default template, not the same as what we saw earlier. If I hover over this profile now, we can see its name. One more thing, if I select the profile view and go to profile creation tools, I don't necessarily like the naming by default that we get for our finished grade profiles. Let's pre-name these as well. If I come over to create profile layout and double click, default name format, profile name template. Let me click on this. I'll click the ellipsis button. I'm going to delete what's there. I would prefer that my finished grade profiles, or usually finished grades what I create first, I would like them to start with the alignment name dash FG. Okay, now that may not be correct in every situation, but that's going to be correct in 90% of my situations. And I can always change it if I have to in the command itself. But for right now, this is going to cover almost every time I create a profile. Let's click OK. So I could do that in my template. Let me select this. And now if I go to Profile Creation Tools, I can see this is going to be named nicely. I'll click OK. And then we'll just do a couple of quick segments here. And if I hover over this, I can see this is nicely named Main Street -FG. Can't emphasize this enough. Make your template work for you. The more work you do on the template, the less work you have to do on every drawing file that you work on. Okay, time's running short. One last thing I want to show you here is with respect to organization. I'm going back to the first drawing here. If we go to the Prospector tab, this is where we can see all the data that's in our file. If I expand the alignments category, centerline alignments, you can see that I've generated a lot of alignments today. Did you know that we can organize alignments into groups just to further simplify things, to make it easier to find what we need? Even though this is already organized as centerline alignments, I may have centerline alignments associated with roads or utilities or swales or, grading or something like that. If I right-click on a header, I can choose Create Folder. I'm going to create a folder called Utilities, and I'll click OK. Let's say that all of these alignments, starting with the word alignment here, are utility alignments. I can select one, hold my Shift key and select another, and then I can click, hold, and drag those into the utility folder. Now I have nice little collapsible categories here. Maybe I could create another folder for roadway. We'll call this roadway, and I'll click OK. And then I will grab both of these and I will drag these in. So I can very easily organize the data that's in my file. If we look down here, if I right-click on surfaces, for instance, you can see that you can create folders organizing your shortcuts as well. Now, I wish that we could apply folders to every category. If you're wondering which categories support folders, it's all of the categories that are displayed down here beneath data shortcuts. So we can do it with surfaces, pressure networks, pipe networks, corridors. By creating folders, you can simplify and make it easier to navigate the data in your models. All right. We're dangerously close to the end here. I'm going to jump back over to my PowerPoint. So today we looked at a ton of tips and tricks associated with alignments and profiles. By all means, if you try a particular tip or workflow with an alignment, try it with a profile and vice versa, because those objects are looked at very similarly. At this point, I'm ready to address any questions.